Rolling into Module 4 here, we have some more networking concepts to cover. NAT and PAT. As I mentioned, we would be revisiting the concept of NAT, and if you remember, this is the function that the router is going to perform to map one public IP to many multiple private IPs within your LAN so that all of your devices can route out to the internet over a public IP address. Putting this chart back in here, we have our private IP address ranges that you should have memorized. And basically, this is an example of our home or our LAN here that has different private IPs assigned to them. And when we have data that goes out over the network, the router will provide a public IP address for use to be able to traverse the internet. Again, this is because we ran out of addresses with IP version 4, and we needed a way to create more addresses with all the devices that need to connect to the internet. So NAT, network address translation, converting a private IP address to a public IP address. Now, what we're really using, and if you go on to CCNA or Network Plus, you'll cover PAT, which is port address translation, and it's mapping multiple private IP addresses to a single public IP address, so still the same concept, but it's using different source port numbers. So it enables multiple devices on a private network to access the internet using a single public IP address, commonly used by all of our internet service providers to conserve public IP address spaces. So instead of keeping track at only the IP layer, it will keep track at the port. So if we had 192.168.1.1, we can have a track of where the router is sending data back in when it comes back from the public IP address to that device, tracking it based on port number instead of the IP number. So PAT is what's really used in production environments, but if you don't care to understand this concept of PAT by looking up additional videos, definitely would want you to know what NAT is and be able to describe it, of why we need it, what function it has, and what devices are doing it. So NAT and PAT. Moving into a concept of virtualization, we have VLANs. This stands for a virtual local area network. So building on our concept of a physical LAN, we can also virtualize our networks. This creates a logical grouping of devices on a network, which can be separated from each other by the switch, know that, router, or firewall. So know that all these devices can logically separate out your network to allow for more networks to be created at a virtual layer. It's allowing you to group. So if this was like VLAN 1 or 10 here, this is VLAN 20, this is VLAN 30, you're able to reserve out some of your area on your switch, router, or firewall to make more networks available to you. You're like splitting them and they're becoming virtual. You can isolate traffic between different groups of devices based on what VLAN they're in. It can improve your network performance. It can improve security and overall network administration of your network. So for example, in a corporate network, the IT department might create a separate VLAN for employees in different departments, such as sales. We might have one for marketing and one for finance. Each VLAN could have its own subnet, its own private IP ranges, and access control policies, and it allows for administrators to control and monitor network traffic more granularly. So let's say sales is going to get a private IP range here in the 10 dot. Maybe marketing will get the 172.16 private IP range, and maybe finance will get 192.168. Or they can all have 10 dots, but maybe this is 10.1, maybe this is 10.2, maybe this is 10.3. So it's a way for network administrators to logically separate out the networks that they have by forming virtual LANs within the network to have better administrative control over the way data is flowing and how they can manage it and increase performance. Another concept is a virtual private network. This is going to offer you a secure communication between two or more networks that allows the users to access resources on a private network over the internet. So the buzzword here is secure connection, and it's going to be basically a tunnel, a secure and encrypted tunnel that you will transmit your data to over a specific secure tunnel designated to you by your VPN client that allows you to access, let's say you're working from home and you want to access your company's resources. A lot of you are probably familiar with the VPN client that you use. You could use, Cisco AnyConnect or a different VPN client, Global Protect, to be able to authenticate with the VPN service, put in your credentials, and then any communication that you do from your home network to your corporate network is going to be secured and authenticated through this encryption tunnel. It's not going to be exposed out on the public internet. It has specific route points that it's going to take based on the tunnel that is created. And this limits it so that if you're working remotely and you need to access your company's, sensitive or proprietary information, you need to be authenticated to the VPN first to then only communicate and access the resources through the VPN tunnel. Cloud service models. We have infrastructure as a service, platform as a service, and software as a service. This chart and this concept will be something that is probably introduced to you in every course that you take, but the main takeaway that I want you to be aware of is the responsibility for what you would need to manage versus what your cloud service provider would need to manage. So some of the leading cloud service providers, we have AWS, the Google Cloud Platform, and Microsoft Azure. These are kind of the leading cloud providers. And when you had resources at your company, it costs a lot of money and more people to manage all of these services that you can have if you have an on-premise solution, so physical and local to you and your business. You'd have to create and manage everything in blue here for your networking, storage, all your servers, your hardware, your operating systems that you're deploying, all the applications that you're running. You have 100% management and responsibility to ensure the uptime, patching, scheduling of anything. Pretty much how your entire network is running is 100% on you for cost, ensuring the CIA of your data is available. Every component that would be involved in that is reliant on you entirely. Cloud now makes it so you can go to Amazon, Google, or Microsoft and say, hey, I need to save some money on people that I have to have hired here to manage virtualization, my servers, my storage, or my networking components. If I go with a cloud provider and you take on some of this responsibility from literally a hardware perspective or an administrative personnel hiring perspective, I can save some money, and you can also guarantee me a certain uptime within our service level agreement document that says, if I go with you to provide these services for me, you can guarantee, 99% of the time, all of my resources are going to be available. So starting with infrastructure as a service, this is the next approach you can take for going with a cloud service provider from on-premises, where you have the most control still. Examples of this would be your massive infrastructure that you can get for virtualization, server storage, and networking when you sign up for a cloud service provider. And if you wanted the cloud service provider to manage even more, you can move into a platform as a service, where the cloud provider is now going to manage everything plus your operating systems, your middleware, and your runtime. So some examples would be, if you've ever played around in AWS, Elastic Beanstalk, Google App Engine, any application service for Microsoft Azure App Service, that would be a platform. So you can still have control over what data you put onto this infrastructure, and you can control what applications you put on there, but you'd only be responsible for these two items here for applications and data if you went with a platform. They're basically providing you with the entire platform you need. You just need to provide your data and applications specific to your company, and they will guarantee and manage the rest. The last section here is software as a service, and you have 0% management of everything. So it's the exact opposite of on-prem, where the cloud provider now manages literally everything. So you're probably very familiar with software as a service if you've ever used Dropbox or any G Suite, Zoom, Slack, Microsoft Office. All of those are software as a service that you can use, like Gmail, to just use. They provide and manage everything as a service for you. You don't need to run, if we stick with the example of Gmail, you don't need to run an email server on-prem. You don't need to make sure all the application and networking and routing protocols or storage of those emails get maintained. You're offloading that to Google through Gmail to provide all of these services for you, and all you need to do is show up and use it. So at a high level, the different types of models you can have with cloud, if you could just be aware that on-premises is your traditional, we work in a building, everything's brick and mortar, and we manage everything on-prem physically. And then as you move from on-prem to software as a service, the management that you have to do decreases and it shifts more to the cloud service provider. That would be ideal. A fun slide here, moving into malicious software known as malware. Just want to cover different types that you can have and a description of them. So starting with a virus, this is a program that can self-replicate by inserting copies of itself into other programs or files. It needs some sort of interaction though. Like a user has to click on something or invoke the program, whereas if you move into a worm, this can propagate rapidly and self-propagate without a user intervention. So it doesn't even need to have a click or someone open something or someone launch an application or double click anything. If you have a worm within your host, it's going to just launch. It doesn't need any sort of start click or anything. A good example is the Stuxnet worm that messed with the centrifuges, unconfirmed or confirmed. The Iranian and US entities were involved in that. But if you want an example of a worm that lived dormant for a very long time and messed with nuclear power plants, centrifuges, I would definitely go out and research about the Stuxnet virus/worm, a Trojan. This is something that's disguising itself as a legitimate software, but it's actually malicious and it will do harm to your computer. So it's a form of malware that looks legit, but it's actually not. A rootkit type of malware that hides its persistence, that hides its presence and other malicious processes from detection by secure software or system administrators. It's going to live in your registry, and this is for Windows. When we cover Windows and the other modules, we will talk in depth about the Windows registry system, and there's 5 main registry keys within the operating system. And if you have a rootkit, it's going to be set in there to do some form of persistence or modification for things that start during runtime, and it will be living inside your registry in the form of a rootkit. Adware and spyware, I'm sure you're very familiar with this. Pretty much just banners that pop up or malware that can give you a bunch of advertisements that you don't want to see, or software that collects data from you. It's spying on you to maybe lead to sales or gain information about your system, and you're not really aware of this as the user, so it kind of gets flagged as a potentially unwanted program or a PUP, and it's just ad spamming or spyware. A macro virus, this is one that can live within anything that uses a macro, and the macro will live in there, and it will be a script or a set of commands that automate tasks or functions within the document. So if we have a Microsoft Word document, there could be a section of a script here or malicious code that would be called the macro virus. And if you interact with this PDF or email attachment or suspicious attachment that comes over in your email. It could be a form of a macro virus that's living within a document. Moving into some basic network attacks that you can have, we have social engineering. This is basically manipulating users at a conscious or more of a conversation-based approach. Social engineering, it's a way for the attacker to gain information about you. Like, for example, if you have your bank account questions to be, what high school did you go to? What was your high school mascot? What is your maiden name? What was the name of your first dog? Someone can kind of social engineer a generic conversation with you to get that information out of you without even realizing that you're divulging your common bank account questions for additional security that you put in. That's a form of social engineering. So people can sit down and talk with you. Another example is if you're on a pen testing team, you can dress up as someone who needs to do some repairing and walk into the building and say, hey, I need you to take me to the server room where I need to do maintenance or check the fire sprinkler system. And you carry a ladder and you go in and you wear an outfit that you look like someone who does, management in that building, but actually you're, performing a pen test and you're socially engineering to fool the person at the front desk to say, oh, I didn't know you were doing anything related to maintenance. Come on in. Here's our server room. And then they give you access. So that's another form of social engineering. Phishing, definitely Starless. It's the type of attack that uses fake emails or websites to trick people into revealing sensitive information or install their malware. There's different types of phishing that you can have, including spear phishing, which is a targeted attack against someone very specific. Whaling, you're going after top-level executives such as CEOs, and farming. So for phishing, just think about you get the email, it comes in, it has an attachment, or it's time sensitive, or it says urgent, I need you to do something, or it comes from your boss to be like, hey, I need you to open this immediately. There might be spelling errors in there. The sender address may not look legitimate, could come from a random Gmail account. I'm sure you have had emails that you've received that look sketchy, and if you were to click on them or interact them or go to the website that they want you to click on in the email, you're subject to a phishing attack. Denial of service. This is an attack where you can have a bunch of, just one here for one denial of service. Hey, you can have a computer out here that is just sending packets here to flood the server and overwhelm it with resources. If we talked about, the TCP three-way handshake, if the server is constantly getting pinned with SYN packets, it's going to need to reply with either the SYN-ACK or some sort of message or even an acknowledgement if it's further down the handshake. That's just one example. But it takes a lot of resources for the computer to be able to send a bunch of replies or acknowledgements. And if you just have a bot out here that's flooding a server or a website, it's taking up allocation of resources from the server to prevent it from replying to legitimate communications from everyone else. So you're DOSing it. You're denying service from legitimate users that want to use it by taking advantage of the resource limitation that a server can perform. So if we stick with a bunch of SYN packets that get sent out, that would be the example of a SYN flood attack. If you did ICMP, that would be a bunch of pings that get sent out. And UDP floods is another example. So basically think about if you had a bunch of computers out here that just ping, I'm sure maybe a good example would be if you were in college and all the test results launched on a Monday at 8 a.m. If everyone's logging in at 7:58 to go check their test results, you could DOS your server that's hosting that information because literally it's being overwhelmed with more people than it's regularly equipped to handle, and you will essentially DOS your educational server that has your test results on it. Anyways, we'll cover more of these in Security Plus if you go on to that, but basically denial of service, you're taking advantage of the resource limitations that a server can have to then degrade it and deny service from legitimate users. Distributed denial of service, this is going to have multiple devices flood a server or network with traffic. Examples can be all of these as well. And this will include botnets. So this is our botnet here, amplification attacks or reflection attacks. Not going to go into depth on what those are. Again, Security Plus will cover them for you, but at a high level, if you can be aware of what social engineering is, what phishing is, and what a denial of service attack is, with a one-on-one here for denial of service, and then multiple to one for distributed denial of service, you'll be in good shape. Moving into IDSs, this stands for Intrusion Detection System. You can have two types. The first type being host-based, which will reside on the client or endpoint. So your laptop, a server, anything that's just a one-off workstation, that's going to be host-based, and it's going to monitor the activity on a single host or endpoint. And we call these HIDs. And they can detect unusual activity on the host, any malware, changes to system files, malicious processes, etc. So each of these would kind of have its own agent running on it to be a host-based intrusion detection system. Whereas if you move into the second type of IDS you can have, which is probably the one I want you to focus on, is a network-based intrusion detection system. This is going to sit in line with the traffic that's coming in over the network before it comes to your LAN or your company environment. You're going to have a device that sits here to say, does this traffic look legitimate? If so, let it pass through. If not, deny it, reject it, or drop the packet. So it's detecting for signs of intrusion or malicious packets that can be traversing the network, and it will drop them and prevent them from coming in. Usually your IDS will sit after your network firewall. You can go and build onto concepts that go into defense in depth. Having multiple points of failure instead of just one single point of failure increases your security posture. But basically, it's looking for anyone that's trying to scan your network, run down the number of ports that are open. Maybe you have an attacker here on their laptop, and they're scanning a bunch of networks to see if anyone has port 22 open on a device. And if so, remember that is SSH. They will try and remote in to that host. If it's found to be vulnerable or open or listening as a socket on one of your endpoints, and if you had a network-based IDS, it would drop that request. If it's not tracking an SSH connection going out from one of the endpoints in your environment, which the router will keep track of, it will drop it. So it's a way to add security to your network. Brute forcing attacks or packet sniffing, again, your IDS will take care of those packets being dropped or rejected. Just a high-level overview of different intrusion detection systems you can have. Remember, you have host-based, which is an agent that lives on the host or endpoint, and then a network-based intrusion detection system that will sit in line for your network traffic.